Because it's strong, powerful. It's called espresso. But some people call it espresso, but that's not quite right.
What is that?
E-X-P-R-E. No. You pronounce it espresso, but in English it's written as E-X. So what did I say? E-X-P-R-E-S-S-O. Espresso. Oh wait, that E-X, you say it as E-S. It's Italian. Yeah, Italian. So it's espresso, not espresso. No, not espresso. Espresso. Close enough.
It's actually ES.
Is it?
Yeah, espresso with an X is a misspelling of the word.
Wow. Okay. No, it is ES, not EX.
ES.
S. Yeah. That just means I've seen coffee shops write it EX a few times. Okay.
Espresso. This one.
You know it?
Yeah, I know this one.
Okay.
That's the taste will, how to say, focus on.
Focus, yes.
On both sides.
Focus, yeah. What have you got? Hot chocolate?
Yeah.
Hot chocolate?
Never tried it.
What is that?
Coffee.
Americano?
Okay, I think it's Americano.
Yeah. What type of coffee?
Just coffee in the machine.
Okay. Write this down, please. Resistivity. Have you got that?
No.
Still having pizza for supper?
Hmm?
Still having pizza for dinner?
No. Today try.
No pizza?
Breakfast.
Pizza for breakfast. Good. Okay, have you got this? Yep.
No.
Do you want me to call Patrick?
No, you told him there was physics, so he might have something to do.
Yeah.
Don't know.
Everything.
Yes, you were. Okay, continue. Yeah, right. So, you don't need to write this down. This is just to get us thinking. All electrical devices, bulbs, TV, PCs, phones, etc., they all have resistance passing through them. They all offer resistance. So, just a bit of vocabulary. A resistor offers resistance. So, this here is a picture of a resistor. Now, this word is important. A resistor is what gives resistance. So, this is a picture of a resistor. There's resistance here. Usually, the work that's done is heat. Is this Patrick now? What happened to you?
I just got candy.
Oh, dude. Right. You're quite a bit late. What happened?
Yeah.
Yeah? What?
I got late from the class and then got candy.
You could have taken your food with you. Like, look at those guys. They're having pizza and sausages. Next time, yeah. Okay, so this is a resistor. So can you please write that word down and try to draw this picture. It's a resistor. So for example, this is maybe a 1 ohm resistor. Can you draw a nice picture? It doesn't have to be nice. Draw a okay picture.
Not to be nice.
No, it doesn't need to be nice. It can be okay.
Expression. E-S-P-R-E-S-S.
Espresso.
No, E.
Espresso.
Okay.
Yeah. But many Irish people say espresso. Which
is okay.
No, no, I don't like it. It's not okay. It's not okay. It's not okay.
Is it wrong? Express.
Kind of is wrong. It should be espresso, not espresso.
The same word, the word.
Because the word's Italian, not English. This is why. Okay, continue. You got this picture?
Nice puppy,
What?
nice puppy.
Beautiful. Right, so this is our resistor. So, what do you think affects the level of resistance? That is, how do you think the OR changes? So if you look at this resistor, what could you do to make the resistance bigger? So what do you think you could do? How could you?
Make it longer.
Yeah, so you could make it longer,
Make it thinner.
Change the
I mean,
material.
change the material, true?
make the diameter smaller.
Yeah, we all got the idea. So if you want to make the resistance bigger, the length, does the length affect it? What do you think?
The longer.
Yes.
Like,
Yeah, you're right, yeah. The radius?
Yeah.
Yes.
More.
Yeah. The type of material, as you said? Yes. So in fact we have a formula to calculate the resistance, and you can see there it's the length divided by the area, and by area I mean the area here on the end, this area, okay? So length is L, A is cross-sectional area, and this rho is a constant. And as you said, Amanda, this will be different for different materials. It's called the resistivity of the material.
different row the density.
Oh yes, we have to reuse some letters. Huh?
I everything now.
Everything in the box.
Is the P in Greek? This row.
It's like a P, a row. Oh no, maybe it's more like an R. I don't know.
Resistance is inversely proportional to area. Like the
Yep.
more it is area and less is the resistance.
More area, less resistance. Yep. Got this? Okay, so this rho is called resistivity, and it's a constant, and it's different for each material. The definition of resistivity is it measures how much the electrical conductor stops the flow of electricity through it. Most metals have a low value of resistivity, and what would have a high value? An insulator, such as
Wood.
wood, plastic, things like this. The units used is the ohm meter. Ohm meter. Okay, so you need this definition. This definition, I've seen it in the exam a few times.
is air like conductor or this insulator? At times it is
It
enlightening and
it depends. It depends. I wouldn't say air is a
maybe it's semiconductor.
no, no. I'd say it's a very, very poor conductor. See, the way I see it, Patrick, is most things are actually conductors, even things which are insulators, because if you pass enough of a current through anything, it will go through it. So you can get a current going across this room if you have a big enough voltage between the two ends. But I generally would consider air more like a no, actually more like a conductor. If you forced me to pick one, I suppose it'd be more like a conductor because lightning travels through air, sparks can travel through air. It's just a very bad conductor. Patrick, can you kind of turn the focus a bit? It's a little blurry. Yeah, just turn the lens. Yeah. Oh, we go. Ah, yeah, much better. Yep, we're good. We got this. Can I continue, guys? Yep. Okay. Now, an insulator will have a notable level of resistance. Yep.
What did you mean by most metals have a very low electrical sensitivity?
Yeah, that the value of this constant for metals is usually quite low. I
Okay.
haven't given you any values yet as an example, but I'm telling you they're usually quite low. Okay. Now, what's an insulator? You've done this in chemistry, have you?
No.
No? Okay, what is an insulator?
It's
Cannot
not
pass
conductor.
It
electric
doesn't
current.
conduct. In other words, it has a lot of resistance.
Yeah.
So I said appreciable level of resistance and will often, but not always, have a high level of resistivity. So in other words, huge resistance.
Even there is a thing, if you can tell me, Schrodinger's cat equation. Something I
Oh yeah, we won't
class.
do that. We won't do that. Do you remember last week when I was talking to you about a surprise and then I said forget about it?
Yeah.
Yeah, that was the surprise. What you were doing yesterday with Dennis. Do you remember that last week I said about the surprise?
No, it's not a surprise.
And then I said, no, I won't talk about it. You'll do it later.
That surprise is killing me.
That surprise was what you did with Dennis.
It's killing me. It's not talk about the listening.
I picked the active listening topic.
I know.
It's killing me.
The
Why
science
you
student
want to
said
tell me
you're
that?
the leader.
Why?
Why you
is
want to tell
that?
me?
It's good for your English. It's good for your physics. It's good
And
for your
not-
brain.
It's not
Can,
good for me to
can you
study the
explain to
source.
me what does quantum mean?
Oh, you'll get that in the active listening lecture.
No,
Oh,
tell
yes.
us.
Yes.
I'm
Oh,
getting my
dear
sauce.
Steven.
Yes.
Oh my god.
You are my sauce.
No. No. Hey, when I was looking in the class yesterday, the sources people had were very good sources. I was quite impressed.
But it's
People
difficult
had-
to find a good sources.
But not me.
Many times find.
Which is unfortunate because it's an engineering topic.
No.
Why did the biology students do better
Yeah,
job?
why?
Yeah, why?
I don't know.
Maybe they're English?
Really?
Maybe. Can you not work together? Maybe they can share the source?
No,
No,
I don't think so.
You don't think so? Well, look, if you find a source and if you email it to me, I can tell you if it's good or bad. Okay? Yeah.
Maybe many times.
Many times is okay. It's okay.
Are you sure? Are you check email at home? No, you don't.
Some days I do. Some days I don't.
Yeah, you have your better laptop at home. Why you don't check your email?
Because I'm so tired when I get home.
But you can see your beautiful, clean laptop.
Yes.
And become
Yeah, and then I open up the dirty student email. Ah. Okay. A conductor. What do you think we can say about conductor then?
it has electric
So
charge.
we have less resistance.
Less resistance. Yeah. So will not offer resistance and will often have a low resistivity.
What about our body? It is conductor.
What?
Our body, main body. It is
Depends how fat you are. The fatter you are, the more of an insulator you are. Yes. Skinny person will be a pretty good conductor. Yeah. Fat person, not so much. I think most people here will be a good conductor. I think so. Yeah. Okay. So let me give you some values, okay? So we take something like graphite. Graphite is in your pencil. Who has a pencil? Yeah, you see the stuff inside his pencil. No, don't you break it. You see the stuff in his pencil. That's graphite, carbon. See, its value is quite low. So in fact, it's actually a good conductor. You see that? Now, copper, you know copper? Metal. Also is a good conductor. Nickel is another metal. It's also a good conductor. And so is nichrome. Wood, now look, see what happens to the power. It goes from negative power to a positive power. And wood is an insulator. What about something like rubber? You know rubber? Like on your shoe, kind of. Insulator. Okay, so these values you will need. Can you write this table down?
I've heard like dry wood is a conductor, but a wet wood can conduct some sort of.
What can?
Like if we put some wood in a water.
Wood?
Yeah.
Oh no,
wet
these
one,
these can.
Yeah.
Like that's my point at the end. You can make a resistor out of a conductor or vice versa, I should say. Anyways. I think, sorry, can you look here? I think that's a mistake. It's not ohm per meter, it's ohm meter, so don't write the -1 there. I don't think so. I think it's a bad conductor. I think. Don't quote me. You got this table? Yeah? Continue?
No.
I find this interesting. I would have thought rubber was bigger than wood, but actually wood is bigger than rubber. That wood has more resistivity. I just think that's interesting. I would have thought wood would be smaller than rubber. And see, copper is very good. Its value is very small. It's the smallest one in my list.
It's smaller.
Yes.
Yeah. Yep. Continue.
No, not yet. I'm sorry, some of us use rulers.
Yeah. Just you.
Only 5 hours I can go for.
5 hours? You're lucky. 6 hours for me.
It's only 1 hour.
Yeah, you go home at 4 o'clock?
Yes.
Yeah, I go home at 5 o'clock.
Every day.
Same then.
Okay. Right, can you write this question down, please? And then I'll do it. You got this? Sophie, you have it already? Yeah. Okay, can I do it now?
Yes.
Yeah. So, what you have, does anybody have an electric heater at home? You don't? You have gas heater in the house?
I don't know.
Okay, let me put it like this. Is the heater on the wall or plugged in?
What? Heater?
In your home,
Yes.
your home state, is the heater on the wall or is the heater plugged in?
On the wall.
So you have gas heater. Okay. Sohi, what heater do you have? Is it electric or gas?
Just ready.
On the wall?
Yes.
So it's gas probably. Electric,
Yeah.
gas. So with an electric heaters are very simple machines. All an electric heater is some nichrome, metal, and then a power. So what happens is when the current passes through it, the heat comes off. So there's resistance here. The work that's being done is the resistor is making heat. This is the work that's being done. And you can calculate the resistance using the formula. So I saw you were looking, Sohi. Can you tell me what the value is for the nichrome?
1.10
Yeah.
times 10 to the minus 6.
Okay. And what did I say the length was? Uh, 20 centimeters?
What formula is this?
The only formula I gave you today.
Okay.
Yeah. Now, in the denominator is the area. So if you look here, it's like a circle. And the diameter is how much? 5 millimeters. So that means the radius is 0.005 divided by 2. So that's 0.005 divided by 2. Let me just write that again. 0.005 divided by 2 pi or squared, because we can use this formula. So I got basically 102 ohms.
Is it always 1.10 times 10 power negative 6?
Yeah, but they'll give you this in the exam question.
How this gas heater works like?
How do I what?
The gas heater work.
The heat happens in the boiler. The gas heats water. It's pumped around the house.
Water
It's hot water that goes around the house. Yeah, yeah.
What is inside our heating like?
Electric heater. It's very, very simple. All it is just some metal, and it looks like this. What they do is inside the heater, you have metal that goes around like this. And it connects to the power. And that's all it is. It's very simple.
It's warmer than the gas?
No, it's the same.
Which one is less fuel?
Which is cheaper?
Yes.
The gas is cheaper. So, if you have a home, it's cheaper to heat the home with gas than electricity.
Why people use electric?
Sometimes it's too expensive to put gas in your home. You have to pay maybe €2,000. But an electric heater, you just buy it from the shop and put it in the bedroom. You know, that's all.
Electric heaters are quick.
Electric heaters also heat up very quickly as well.
So
Yeah.
why people buying two different?
Why do people what?
Choose different heaters.
Depends how much money they have.
Okay.
Also, electric heaters, like he said, they can get hot very quickly. So can gas heaters. It depends on the gas. Yeah.
In school is gas.
In school building, it's gas. But in this building, the accommodation, like his bedroom, you're in accommodation, aren't you?
I am.
Oh, you are. The electric heaters are on the wall.
No, it's also gas.
Oh, it's gas. Okay, no, the school is gas. Yep. Okay. It's 4 questions.
Is it homework?
Yes.
What do you think, Amanda?
I
Not
think
homework.
it's just I see and forget.
No, it's not that. It's homework. You see and you do.
You see and forget, the other one.
Not in my mind.
As usual.
Okay. Right. Do you want to take a short...
No.
Yes.
No.
Listen, you came late because you were in the canteen, so we don't count your opinion. What about you two?
I don't mind.
You want to rest a little
Yes.
because my class was so difficult?
No.
Okay, take a little break.